Professor Cook, what are chemical reactions?
Well, Jimmy, chemical reactions are a process in which atoms of the same or different elements rearrange themselves to form a new substance. We will further explain the forms of these processes shortly. First, we'll start out with some definitions. An element is a class of substances that cannot be separated into simpler substances by chemical means. The next definition is a compound. This is two or more elements chemically combined. They are in a fixed ratio, can be broken down into simpler substances using chemical reactions, and has properties that are different from its component elements. The first form of a chemical reaction is a synthesis reaction. This is where two or more substances combine to form a single substance. An example of this is shown below. A plus B combines to form AB.
Professor Cook, are there any other types of reactions?
Of course there are, Jimmy. The next reaction is a decomposition reaction. This is where one substance breaks down into two. An example of this is shown by AB breaking down into A plus B. Two more types of chemical reactions are replacement reactions. The first is single replacement. This is when one element reacts with one compound to form a new compound in an element. The next is double replacement. This is when two compounds react by changing partners. In the examples shown, the arrows represent the replacements that happen during the reactions.
How many more reactions are there, Professor Cook?
Only one, Jimmy. The final type of chemical reactions is a combustion reaction. This is when a compound containing carbon and hydrogen, and sometimes oxygen or nitrogen, reacts with oxygen to form carbon dioxide and water. This type of reaction does not occur too often, so you will not need to worry about it that much.
But Professor, how would I write a chemical equation given the word equation for a reaction?
Easy, Jimmy. If manganese reacts with nickel 2 sulfate to produce manganese sulfate, then you would write down each substance using the periodic table and table E for the polyatomic ions. From there, you would separate what is together on each side using a plus sign, and an arrow would separate the reactants from the products. Finally, you would balance the equation based on the substance's charges. Here's a key concept for this lesson, Jimmy. Chemical changes produce products that have new and different properties from the reactants.
But Professor Cook, how could I determine the missing product without giving the full equation?
It's quite simple, actually, Jimmy. To determine the missing products, you would first find the substances on the reactant side not present on the product side. In the example shown, these are iodine and sodium. Then you would write these substances in order of metal-nonmetal, Na2, I2. Finally, you would simplify the charges using the crisscross method. The next topic we need to learn is predicting spontaneous reactions for single replacement. If a free element is trying to replace an element in a compound, it must be higher or more reactive in Table J. So simply, you would just find each element in Table J, and if it is higher, it will replace the reaction and it will occur spontaneously. In the example, Mg is above Cu, so Mg replaces it and the reaction occurs spontaneously.
Professor Cook, can a double replacement reaction occur spontaneously?
Pay attention, Jimmy, I was getting to that. The final topic to learn is predicting double replacement reactions. For a double replacement reaction to occur, at least one of the products has to be either a precipitate, an insoluble solid shown in Table F, a gas, or a molecular compound such as H2O.
Thanks, Professor. I sure know my chemical reactions now.